Alright, so let's take a look at L'Hopital's rule. Um, it says here, suppose f and g are differentiable on an open interval I containing a, with g prime of x not equal to 0 on I when x is not equal to a. If the limit of f of x and the limit of g of x as x approaches a are both equal to 0, then the limit of f of x over g of x as x approaches a is equal to the limit of f prime of x over g prime of x as x approaches a, provided the limit on the right exists or is plus or minus infinity. And the rule also applies if x approaches a is replaced with x approaches plus or minus infinity, or approaches a from the right or the left. Alright, so what we're dealing with here is if we're taking the limit and we plug this a in for x and we end up with 0 over 0, then L'Hopital's rule is saying we can take the derivative of the numerator and the derivative of the denominator and the limits will be the same. And it's also going to be true if we plug a in for x and we get infinity over infinity or negative infinity over negative infinity. Okay, we can do the same thing. So in this video I'm gonna do two examples, and then I'll post some more videos with more examples. Alright, so let's take a look at the first one. Alright, so it says it wants us to find the limit of e to the 2x minus 1 over x as x goes to 0. Now you can see if we plug 0 in, well, e to the 2 times 0, that's just e to the 0, which is 1, and 1 minus 1 is 0, and then if we plug 0 in here, we get 0, so we have 0 over 0. So we can use L'Hopital's rule that says that is equal to the limit as x approaches 0, and we can take the derivative of the numerator. So the derivative of the numerator is e to the 2x, and then remember, times the derivative of the exponent, so times 2, over the derivative of the denominator, which is 1. Alright, so this is going to give us the limit as x goes to 0 of 2e to the 2x. Now let's plug the 0 in. So we get 2e to the 2 times 0, which is 2 times 1, and this is e to the 0 is just 1, which equals 2. And there's our answer. Alright, let's take a look at example 2. Okay, the limit natural log of x over x as x goes to infinity. Alright, so let's take the limit as x goes to infinity. Well, as x gets big for natural log x, as the x values get big, the numerator goes to infinity, and then of course if we plug big numbers in for x, that goes to infinity also. So we end up with infinity over infinity. So that means that equals the limit as x goes to infinity, and we can take the derivative of the numerator and the derivative of the denominator. So the derivative of the numerator, derivative of natural log x, is 1 over x, and the derivative of x is 1. And so that gives us the limit as x goes to infinity of 1 over x. Alright, so now x is getting really big. So as x gets big, that means the denominator is getting really big. And as the denominator gets big, well, what is the whole fraction doing? Well, it's going to 0. And there's your answer. Alright, so I hope these two examples help. They're pretty easy, pretty basic. I'm going to post some more videos. I hope you'll watch those. So if you like them, you can subscribe, and thanks.